Welcome everybody. Today we're going to do a quick energy review as we get ready to think about how energy plays into electricity. To do that, I'm going to think about a relatively simple example using our basic mechanics and energy knowledge with this apple. I'm going to do two experiments. In experiment one, I'm going to take this apple, hold it up here, and then I'm going to slowly lower it down and then put it on the ground. And then in experiment two, I'm going to take that same apple and I'm going to hold it at the same initial height, and then I'm going to drop it and think about what happens between the moment I drop it and the moment right before it hits the ground. So those are the systems that I'm thinking about. In both cases, I'm going to make a system that consists of the apple and the earth together. You can pick your own system when you're working on this question if you want to. So experiment one, again, I'm lowering the apple by holding onto it. In that case, my hand is going to act an external force, which will point upwards. The apple's motion is downwards, so the work done by that force is going to be negative because the force and the displacement are pointing in opposite directions. I can figure out how big it is if I want to, but I'm mostly going to think in qualitative understanding here. I know from the work energy theorem, which says that the work net external is equal to the change in total energy, that if I have a negative net external work, then I also have a negative change in the total energy of the system. I observed that the kinetic energy of the apple didn't change because it started at rest and it ended at rest. So I have no change in the kinetic energy. And of course, the total energy is equal to the sum plus delta K plus delta U of the two different kinds of energies. So if I don't have any change in kinetic energy, but I do have a change in total energy, I need a negative change in the potential energy. Now if I go over to experiment two, where I did a different thing, I took the apple and dropped it. Now I have no external force by the hand. There aren't really any other external forces since I'm putting the earth in my system. Gravity is an internal force that can't do external work. So I have no work done by external forces, therefore no change in total energy. I do now have a change in kinetic energy because the apple went from not moving to moving. So I have a positive change in kinetic energy. And then again, because the total energy is the sum of kinetic and potential, if I have a positive change in kinetic energy, I need a negative change in the potential energy so that those two things will add up to zero.